Hi class. For our first unit, we have some introductory material to computers and operating systems, and of course this is very important material. We also want to understand the relationship between Java and the World Wide Web. Um, Java is the kind of programming language that is designed to be open, right? It's designed to run on most any operating system because it runs in its own little world, its own little Java virtual machine. When we go to run a Java application, the Java virtual machine is created and then our program is launched and run in the virtual machine. So we can use Java on any operating system that supports Java or Java has support for, which is a very, very wide array of operating systems. So Java has been freely available for many years, so it has a very wide install base. We have some specific language specifications to understand. API stands for Application Programming Interface. This is a connection point, usually on the internet or the World Wide Web, that allows one application to communicate with another. For example, if I sold things to Walmart, I would connect to Walmart through an API to transfer my billing information to them or whatever information I needed to transfer. The API would allow me to do that. JDK stands for Java Development Kit. This is software that must be installed in order to develop Java programming instructions. You'll see that we can use cloud-based development tools that make it where we don't have to actually install the Java Development Kit on our own computer or operating system. But as we get further along in our development, we'll want to do that so that we'll experience the complete Java environment. In addition to the development kit, we'll need then an IDE, an interactive development environment that assists us in our Java code development. We could use something as simple as Notepad to type our code, but then we would have to use the command line and be aware of command line prompts to compile our program source code into code that is executable by our Java virtual machine. So we would have a lot of underlying knowledge that would be necessary. An interactive development environment takes care of a lot of those things for us, making it easier for us to do program development. We again will get into our development environments as we gain more experience. For now, we want to learn how to write a simple Java program that just displays output on the console. Now, what is the console? Some people may think of an Xbox or a device like that right away when I mention the word console. That's not what we mean here. We're talking about the Java console, the output screen where messages for the computer will be displayed. So not a gaming console, but a computer console like a command prompt screen. We're going to be looking at some basic syntax of our Java programs and see how to create, compile, and run them. We'll talk from the very beginning about using good programming style and adding comments to document our programs. We'll look at the difference between different types of errors in our program. For our first program, I'd like to use Revel and look at the sample projects for the chapter. So I'm going to click on my Pearson Revel link and open Revel. And of course, I have to look at the complete textbook to see the material. You can click simply on the assignment. Either way should be fine. Now I'm going to look here a little bit at section 1.7, a simple Java program. And in this area, we're seeing the beginnings of a very simple program. When we execute a simple Java program, the operating system is going to start our program at the main method. The main method is going to be something that the operating system or that Java virtual machine is looking for, is an entry point to begin your Java program. When we're working with our Java programming in a basic mode, we'll be working with a console program, meaning that input would come from the user console and output would be displayed on the console monitor. Now, this is an actual video here, and I will let you watch that later. We're going to skip ahead and look at this code animation. I want to turn my volume on, and let's start this.
Check your understanding. Note that in all code animation, you can use mouse or finger to move highlight, explanation, output, and check your understanding box freely. Does the program start the execution from the main method? Answer yes or no.
Well, yes it does. We just discussed that.
You are correct.
Yay!
The program starts the execution from the main method.
Okay, now the video or the animation is pausing to let me take a look at this code. I noticed that my main method does have this word main in it. It's kind of buried though. It's within this public class statement. Now I want to point out to you these square or curly brackets. The curly braces are important and they are required. So we have to have matching opening and closing curly braces. So if I look at this code, the first thing I see is this public class statement. It's very simple. I don't need to worry about it too much. Especially at this point, will just put whatever Revel tells me I need to there. But I do need to notice that there has to be an open curly brace after my class name. And then at the very end of my source code, I need a matching closing curly brace. If either of these curly braces gets removed or eliminated, I'll have a syntax error or a coding error in my program and I won't be able to run it. Now, besides the class having an opening and closing curly brackets, so does my main method. If you notice, here's the opening curly bracket for my main method, and here is the matching closing curly bracket. Now I'm going to go ahead and click next to continue on with this animation.
The statement displays welcome to Java. To the console.
Okay, so this line of code here, system.out.println with the string enclosed in double quotes, welcome to Java, is going to print the message, welcome to Java, on the output console. Now, that's all this program is going to do. It's our very, very first piece of code. Now let's click next to continue on.
The main method exits. The program is finished.
So that's all our program did. Awesome. Now let's try it as a live example. In the live example, we see basically the same code, except that here line 4 is missing. we have to fill it in to solve this. So I'm going to click there, and I'm going to copy that code, and I'm going to copy it exactly. Uppercase, lowercase, abbreviation, all of those things are required for my Java syntax. Syntax is the rules of the language, and we must follow the rules. Now, after system.out.println, I have an open and close parenthesis, and inside the parentheses is the actual message I want to display, which is welcome to Java exclamation point. Now, the only other thing I need is a semicolon to close out my line of code. So I will add that. Notice that Java code requires a semicolon at the end of each sentence or line of code. I didn't have a semicolon on my main method or my class statement because those statements use curly braces. They're kind of an alternative. All right, I think I've got this right. So I want to compile and run it. I should see some messages down here. Try that again. Oh, it's doing it. It says that it compiled successfully, and when it was run with this command, I got the welcome to Java output. Now I can do automatic check to make sure that my output is correct. And it says, yep, you did good. Now let's try a couple of things. If I leave out that closing semicolon, will I be able to compile and run? Nope. It says that in welcome.java, which is our file, on line 4, there is an error. A semicolon was expected, and it even shows us line 4 here with the little caret character showing us the position where the problem was encountered. So right here, I need that semicolon. Now what if I leave out something else, like one of these double quotes? Let's try. I'll do a compile on that, and it says, oh, again, I've got a problem. You had an unclosed string. A string is just a bunch of characters, and anytime we use a string in our Java code, we have to have it enclosed within double quotes. And the messages are telling us, I think you were working with a string, but you didn't end it right. So let's fix that. Now, Revel is helping me by giving me 2 of them. So I have to figure out a way to get rid of that second one without Revel helping me too much. What about, say, this uppercase letter S? What if I accidentally made it a lowercase? Let's run it. Another syntax error. Again, I'm told this package that you named, system, does not exist. Now this error isn't quite as helpful, is it? It could take a little bit more work. So being really careful with our casing as well as our typing of variable names will really help us. Okay, so any error like that that keeps our program from compiling is a syntax error. In our little program, we don't do very much. We just print out this message. So we can't generate a logic error unless we made our message wrong, right? What if I made a typo there? Now my program is going to run, but the output is not correct. We could almost call that a problem in logic. We know it's just a typo, but the end result is the same. Our output is not what was expected. That's a logic error when our program runs, but it doesn't give us what we expect for output. We still have to do some debugging. We just don't know where the problem is because we don't have the compiler helping us. Now I can tell I just have a typo there, so I can fix it and then be on my way. The third type of error we can encounter is a runtime error. And a runtime error happens when our program does something illogical that causes it to fail in execution. For example, if we try to divide a number by 0, that would not work because that's an illogical math problem, and so we would end up with a runtime error. So the three types of errors: a syntax error is there's something wrong with the actual code, we can't compile it. A logic error is the code seems to work, but our results are not as expected. Something is not working properly. And then a runtime error is when our program cancels. As we look at this utility, we can see that with Revel, you have a lot of great opportunities to practice as you're going through the content, because they show you the code, then they ask you to type in some of the code, give you an opportunity to check and make sure that you did everything correctly. So I want to copy this. I'm going to Control C to copy it, and I'm going to go to the programming exercises from the book. And I want to work on this first programming exercise. And it says that we want a program to display 3 messages. It should display welcome to Java, then welcome to computer science, and then programming is fun. Well, I can do that using this test tool up here at the top. I'm doing chapter 1, exercise 1. So I'm going to paste that code I copied, and I have just about everything I need, except that I'm supposed to have more than one message. Welcome to Java, welcome to computer science. Okay, so right after line 4, I need to add a new line of code because I want another message to be generated. So I'm going to use the same exact code, system.out.println, because I found that makes a message be displayed on the console. In this message, I want to say Java is fun, and I'm going to close that line of code with my semicolon. Now I'm going to compile and run. Oh, it gets mad at me. It says, this check exercise tool is currently set for checking exercise 01_01. Please define your class as public class exercise 0101. My class name is welcome. So let me change that. Exercise 01_01. Okay, are you happy now? Let's try it. Ah, we are. Now, we see that our code was run, and we output 2 messages, welcome to Java, and Java is fun. If I look at our instructions, oh, I didn't quite do that right, did I? I should say welcome to computer science, and programming is fun. Well, I could use this automatic check tool to remind myself of that. Here we go. Oh, there it is. It says, here's your output, but the correct output should be like this. All right, so let me fix it. For my second output line, I should not say Java is fun. I should say, welcome to computer science. And then I need a third message, system.out.println, programming is fun. And then I need to close that with a semicolon. Now I'm going to try my compile. And I see I've got 3 messages. And now I'll try my automatic check. Your program is correct. So it was able to determine that the output that I generated was the same as what was required. So I can use this automatic check tool to do all sorts of great things and check my code. I think that that is great progress for us today. So let's congratulate ourselves for writing that first Java program, and do feel free to work through some of the additional assignments that are included in the programming exercises from the book for Chapter 1. But don't forget, your points will be awarded from doing the programming projects that are assignments. When you've completed those in Revel, your score will automatically be uploaded to Canvas. So you should see that grade show up in Canvas soon after you do that assignment. We'll keep an eye on that, and sometimes I might have to give Revel a little bit of a kick in the behind to make it post things to Canvas, but that should happen automatically. Now enjoy these tools. Remember, we're going to have a lot more tools to use as the semester progresses. These tools are for beginners in Java. So enjoy yourself and have some fun with programming. Thank you.